Hello everyone, thank you all for coming. My name is Julian Edwards, a DBA student at the California Intercontinental University. Today we'll be looking at applying the chi-square test of independence. For our presentation today, we will be defining the chi-square test, followed by looking at Cramer's V. We'll then move on to conducting the chi-square test to the GRC 605 dataset, and then conclude with our main takeaways from this presentation. The chi-square test is a statistical test used to test hypotheses when variables are nominal. It provides the significance of differences but also provides detailed information on categories which account for any differences found. It is a test of significance and should always be coupled with an appropriate test of strength. This test is Cramer's V. It is an appropriate strength test for the chi-square test and is a form of correlational test. Now, from our data set, our first relationship we looked at was the number of cars versus the number of default payments. So our first categorical variable was number of cars, with our second categorical variable being number of default payments on said cars. Our null hypothesis was found to be that there was no relationship between the number of cars and the number of default payments, while our alternative hypothesis would then state that there is a relationship between the number of cars and the number of defaults. Our rejection rule, we will reject the null hypothesis if p is less than our alpha value of 0.05. Our post hoc rule is if we reject the null hypothesis, then we follow with Cramer's V. The chi-square statistic and its p-value were calculated using PSPP, assuming an alpha level of 0.05, and a relationship emerged of chi-squared yielding a value of 9.70 at 9 degrees of freedom with 150 cases. Our p-value was found to be 0.375, which in this case is not significant, and as such we would fail to reject null hypothesis. Our Cramer's V value was found to be 0.15, which indicated a weak relationship, and this is represented from our chi-squared value is shown to be 9.70 at 9 degrees of freedom with our significance at 0.375. Below we see our Cramer's V value of 0.15. Our second test was Likert comfort scales versus the number of default payments. Our null hypothesis was stated that there is no relationship between the comfort scale and the number of default payments, while our alternative hypothesis stated that there is a relationship between a comfort scale or Likert scale and the number of defaults. A rejection rule states that we reject the null hypothesis when p is less than our alpha value, which is set at 0.05, and our post hoc rule again is if we reject the null hypothesis, we have to follow with Cramer's V. The chi-square statistic again and its p-value were calculated using PSPP, assuming an alpha level of 0.05, and a relationship emerged similar to the test before, where chi-squared value was found to be 9.70 at 9 degrees of freedom with 150 cases. A p-value found to be 0.375, which is not significant, and as such we again fail to reject null hypothesis. Cramer's V indicated that there is a weak relationship with a value of 0.15. And again, represented with our output from PSPP, chi-squared value of 9.70 at 9 degrees of freedom, the significance of 0.375, and Cramer's V of 0.15. Our final test was to determine if there was a relationship between the number of cars and the Likert comfort scale. Our null hypothesis was stated that there is no relationship between the number of cars and the Likert comfort scale, while our alternative hypothesis stated that there is a relationship between the number of cars and the Likert comfort scale. Our rejection rule stated that we reject the null hypothesis when p is less than our alpha value that's set at 0.05, And if we reject the null, then we follow with our Cramer's V. The chi-square statistic was again calculated along with its p-value using the PSPP software, assuming an alpha level of 0.05, and a relationship emerged of a chi-squared value of 450 at 9 degrees of freedom with 150 cases. Our p-value was found to be 0.000, which is highly significant, and as such, we would reject our null hypothesis and follow with our Cramer's V, which was found to be 1.00, which indicated a perfect relationship. This is represented with our output from our PSPP software, where our chi-squared value was found to be 450 at 9 degrees of freedom, our significance value 0.000, and our Cramer's V value of 1.00. Our main takeaways from this presentation is that the chi-square test is useful to determine the significance of any differences between observations. It provides information on which categories account for these differences, and it couples with the Cramer's V test as a strength of correlation. I want to thank you all so much for attending. If you do have any questions or comments, please feel free to ask.